who you are and the project you're working on, and I'm happy to go first. So I have the honor of moderating today here. My name is Wuollet. I'm one of the investors at a16z Crypto. Regan, please take away.
Hey. Yeah, I'm Regan. I'm an engineering head at PINAI. At PINAI, we were trying to build a coordination layer for personal AI. We got several protocols like personal data protocol. We got the decentralized internet matching protocol, and we got an agent service protocol. That we were trying to build a foundation for the new work for Web3 plus.
Hey guys, I'm Saneel. I'm on the founding team at Ritual. So Ritual is one of a few things. Our first phase, Infernet, was sort of the first Oracle network dedicated to bringing AI inference on-chain. That combines a set of nodes that run models off-chain, compute agnostic, and an on-chain SDK paying for inferences and associating proofs. And the second phase, which I think we'll be revealing a lot more details literally next week, so it's maybe a bit premature, is the Ritual chain. So the Ritual chain does a lot of really fascinating work at the consensus and execution layers around ensuring the ability to do certain AI operations like inference and fine-tuning natively. So any developer can come, write a smart contract, accent the models that are endemic to the network, without generating anything else, go and run inference for fine-tuning ops, both protocols, monetize their model, etc. I can go into more how we do that because I know one of the questions is that, but yeah.
Hey everyone, I'm Ben, co-founder of Gensyn. We build very low-level machine learning infrastructure to make machine learning as ubiquitous as it possibly can be in the world, basically kind of accelerate machine learning as much as we can. Most people know us for the compute protocol that we build, so the idea behind that is to allow machine learning operations to be done on any device in the world that's capable of doing them, at any time, at any scale, without the kind of current barriers that you have. And those barriers are things like actually doing execution of ML tasks on these devices, software-wise, verifying that the work has actually been done so that you can send it to an untrusted device, and doing it efficiently at scale as well. So can I build a model over 1 million MacBooks instead of building a model over a centralized data center or something like that?
Perfect. So the question I want to start with, I think it's interesting oftentimes this category or space is called crypto AI or Web3 AI or decentralized AI, and those all are a little bit amorphous. They were kind of talking about two enabling technologies as opposed to product experience or the end purpose for what each of you are building. So maybe Ben, starting with you, I'd love to ask you what decentralized AI means for you and for Gensyn. What is kind of the purpose behind the technology that you guys have spent so much time building?
Sure, yeah, so we're pretty opinionated about this. To us, decentralization is ultimately a scaling technology. It allows us to take away barriers that exist in the centralized world, typically like human barriers. So compute, the main thing we think about at the moment, when you think about compute, if you want to access it, typically you have to take a lot of hops through the normal world. You have to speak to various people who run companies, who have hardware. You have to go through lawyers to get contracts, to have SLAs, etc. Essentially, there's lots of kind of things that slow down your access to that resource, but fundamentally, underneath it all is a resource. It's electricity being turned into machine learning operations. Decentralization as a technology gives us a way to go directly to that resource. We don't have to take those hops through the human world like we used to. We can actually just access the resource directly, programmatically, and scale kind of essentially infinitely. That's absolutely essential for us to scale machine learning, but also essential for us to make it more automated. If you think about, in the future, a machine learning model itself accessing compute, that's a pretty logical thing that could happen now. Previously, it was pretty crazy. But for it to do that right now, we'd have to go and talk to an AWS exec to get access to compute, and it's not going to do that. What it needs to be able to do is just call some kind of endpoint and be able to trigger the execution of the compute, pay for it somehow with some kind of digital currency. You see where I'm going? All of this technology allows us to essentially provide automation and unlimited scale. So that's the way we think about it. Very much infrastructure to enable something in the kind of Web2 world to be done way more efficiently at a way higher scale.
Cool, yeah. I think the way that I think about it, I'll start with going back to what I think Ethereum uniquely enabled when it launched, which was that it took the computer and made it a globally shared public good. And that shared state, and it made it multiplayer, right? So now people can come write contracts on the same substrate, they can interact with each other. And the end product of that was, yes, open access and decentralization were big features of that, and the end product of that was that we saw crypto probably become the fastest growing software technology of all time, only then to be eclipsed by AI, right? Maybe why it's kind of topical. And I think a large portion of that was that some of you knocked down, like, as Ben alluded to, a lot of the human factors that go into rapid application development, because now you have this globally shared compute layer. And so at Ritual, I think we think about it much in the same, but now scaling this to generalized AI models. But the challenge there is that a single deterministic computer is pretty easy to do. A bunch of nodes can run it. Yes, there's like difference in maybe execution times, but it's largely the same. AI computing models are not that, right? They are very heterogeneous. You have different GPUs, you have different model architectures, and whatnot. And so for us, the big challenge, which I will go into later, is how you coordinate that. But the end result of this, and then the end purpose of this, is basically capture those same dynamics around incentives and open access that accelerate sort of like developer adoption and apply it to models, right? So the end result of having now one that can automatically work with models, that now anyone can come develop an application and access any of these models at any given time, and hopefully that creates a much greater pace of innovation and experimentation. I think we've already even seen this with existing infrastructure that is not necessarily purpose-built for AI. The last part I'll mention about this is that, going back to the human factors point, I think structurally there's a lot of economic value lost when you go into the realm of like regulation or geopolitics, etc. Right? There's this large swath of the world that ChatGPT is not accessible to. There's a large swath of the world that has developed their own models that are necessarily inferior. But those parts of the world may have very competent and quote unquote aligned developers, right? That would be useful in developing applications, pushing the bounds of what crypto AI can be. So from a utility perspective, having the right incentives and having the right distributed systems in place to make sure that they can access AI models as long as they have internet connection in a stable way and not be geofenced by centralized entities. Hopefully, may lead to some bad stuff, but hopefully that ends to be net positive, which I think Ethereum has. I think in Bridge we hope that it'll much the same way with models.
Regan, tell us what decentralized AI means for you and for Penn.
Sure. I think actually decentralization in PIN means two things. One thing is about data, and another thing is about open market. In the sense that, so from the data's perspective, right now, for those big like Web2 companies, for example, Amazon, you go there, actually the back-end system of Amazon, they already know who you are. So whatever cookies and the other tracking techniques and your preference and your history, all the data is in Amazon's back-end, right? So you can potentially kind of pull out your Amazon purchase history, that kind of thing. But it's really kind of hard. And also you won't be able to monetize that. And so what we were trying to do here is that we want every user to be able to pull the data from those big Web2 companies, because this data is valuable and can be monetized. So we want each user has their own data sovereignty, and their data is valuable and can be monetized. This is one aspect. And then I think another aspect is the open market, in the sense that in the Web3 plus the AI world, everybody will be able to do the AI agent and then let the AI agent kind of live on-chain and online and to provide service. So I think none of these kind of centralized platforms will be able to allow that. And I think that is the gist of decentralization, and that's something centralized platform won't be able to power.
Perfect. So now that we have a sense for some of the problems you're solving and what kind of this whole space means to each of you, I'd love to ask what some of the primary technical challenges you guys have faced are, what maybe some of the open problems that you're interested in seeing, hopefully some of the other developers in the audience tackle. Maybe Regan, let's start with you. What are some of the interesting problems you guys have solved?
Sure, actually a lot. So for example, we have our kind of on-device AI model. So how to make that model efficient and also to be able to serve the user's needs. Because I think for our case, we don't need a model that can be living on device that tells you how to code or do some other things that is not quite related. We want this model to help you kind of finish the daily tasks. So that has to be kind of attuned to serve the purpose. And also the performance-wise and latency-wise for token generation, yeah. So that is the kind of a challenging on the on-device model side. And also, we will have like a hybrid approach in the sense that if the on-device model wouldn't be able to finish the work, then it will be needed to kind of to route to the cloud AI to help you solve the issues. Then that brings another problem regarding the data privacy, right? Because the reason that we want to kind of have the model on device is that it can strictly protect your privacy. So how to enable that kind of a personal the PCC environment and how to utilize the TEE to help protect the data privacy is another thing. And also regarding the kind of intent matching thing we were doing here, what would be the correct algorithm, and how do we make sure that the best agent will be able to kind of chosen to serve the user's purpose. That's another aspect.
Yeah, to iterate a lot. So I'll run through them in rapid fire. First, when you're dealing with heterogeneous compute, which you will be with any AI model, you have different GPUs and different classes of model architecture. That is not suited for typical on-chain fee markets, right? In fact, fee markets on things like Ethereum are already incredibly inefficient because they try and deal with pricing multiple resources with the same unit. And that goes even crazier into higher dimensions when you're dealing with different hardware and different actual programs to be run. So the first thing that we have there is we have developed certain mechanisms and maybe instructions that get closer to what a, in theory, optimal market might look like for that in terms of user has an express preference of what they want the models to do and how much they want to pay. And on the other end, you have people that are compute providers who also have their preference on how much they want to accept and what they're willing to do. And then there's a matching problem between them. So that's one, right? That's how you make sure that you're not literally just pricing model calls and computation using basic fee markets. Two is like when you are thinking about folding the execution of models, their inputs, their outputs, into the critical path of the chain, which includes consensus and execution, you run into this thing that in a typical blockchain computer, so all the nodes can very easily, all the flow nodes can very easily verify that transaction in leads to transaction state out. But with models, some of them are deterministic and some of them are not deterministic. And more importantly, they can be either very cheap or very expensive objects to run. And again, going back to heterogeneity, it doesn't make sense to have all the nodes in the chain re-execute a model every single time. So we spend a lot of time working with both internally and working with external partners and companies to build interesting verification and proving schema for models from TK to TEs that eliminate any need for redundancy and any risk from non-determinism that may impact the critical path of consensus when you're making sure that the model output leads to some state change. What else? There's a lot of issues around potentially model privacy and input privacy, right? So sometimes someone may have a model, but they don't want to divulge the weight, they want other people to go run it, right? Or say that you have an input, you want someone to run the model, etc. So you probably have heard FHE, MTC. FHE is, I think, getting there, and it's definitely promising, but it's still late in production. We do think that there are specific use cases in which MPC does make sense rather than having people run models blind. So I have an open source model, you can agree whatever the individual weights, but you'll run it for me. Yes, you take the latency hit off, but there are certain privacy sensitive use cases where that's okay, right? Same thing for input. So we do a lot of great work with Millie and Fairblock and a bunch of other partners on that front. There's a bunch more and I could keep going, but I'm going to cap it there. Sorry, Ben.
No worries. There's going to be some overlap in what I say, but principally for us, there's three main things that we work on that are particularly challenging technically. So verification is one of them. We've heard a little bit about it, but the idea that you can trust the execution of a machine learning model on a device without having to rely on one of those human world mechanisms like reputation or relationship or legal contract or something like that. So we want to go right down to the operations themselves and be able to know that those operations were done as they said they were, entirely programmatically. And we spent a long time working on this. We've been working on this for more than 4 years. In that time, we've sort of taken a bit of a progression from searching for a silver bullet solution, i.e. can cryptography just solve this problem? Can we do ZKML and therefore we know that verification just works? Or can we have a game theoretic solution that can get to a security bound that's just enough that actually you can just rely on that? The secret is not really. It's entirely use case dependent. Certain use cases require enormous amounts of security, some require surprisingly low amounts or even no verification because you can do human level verification, i.e. if I generate an image and I look at the image and it's terrible, I can verify that probably what I asked for hasn't been done, and you can do that instantaneously. So in those situations, the verification can be very lightweight. But in the end, the conclusion we've come to is you need a box of kind of tools for verification. You need to be able to expose those tools in the right way so people can apply them to their use cases. So we spent a long time building that. We use all of the techniques you can think of, cryptography, game theory, probability, etc., to do verification. The second big thing that we do is execution. So as I mentioned before, we want machine learning operations to be done on every device in the world that's capable of doing them. But there's a lot of kind of tech in the way of that. Like if I want to execute ML ops on somebody's iPhone right now, it's actually surprisingly hard for me to do that because of the software stack. So we build a new compiler which goes from high-level frameworks all the way down to execution on individual devices that can scale across all devices. So if somebody builds a new machine learning processor, actually it's very easy to build it into our stack, into our compiler, because you just need to build the low-level execution framework for the compiler itself. And that ties into verification because a key part of that is determinism. Our compiler can do deterministic operations so that you can check them, you can redo them, etc. You can wrap them in zero-knowledge proofs, whatever you need to do. So that's the second thing. Third thing is efficiency. It's all very well and good to say that we can verify, we can trust every device in the world, we can send MLOps out to it. Is that actually efficient if I build a model over it? In the machine learning modeling world, not really right now, because we've spent a very long time making centralized model development efficient and a very small amount of time making it efficient across data centers and even across kind of like heterogeneous consumer devices. But it's very possible. You just have to change the way you build models and do scheduling techniques which are optimal for that specific infrastructure. And it turns out if you kind of zoom out on that and say, hey, I've got this weird heterogeneous network, you actually just have a really interesting optimization problem. You've got weird communication costs, weird compute costs, but you actually have a nice landscape to optimize if you approach it as an optimization problem, rather than assuming communication costs are zero and just splitting the model in the most naive way, which is kind of how we've done it for the past 5 to 10 years, essentially. So yeah, those three big things: verification, execution, and efficiency are what we spend the vast majority of our time on.
Perfect. Now we have a sense for the problems you're solving, how you're solving them. I'm noticing a strong sense of infrastructure on this stage, and I'm going to try to have a little bit of a hot take and inject an interest in applications. I'd love to hear from each of you who you think the most important users of your protocols will be, where they will come from, and how you're thinking about acquiring them. What takes Gensyn, Ritual, and PIN from an interesting idea for infrastructure to something that is pervasive and we're all using every day?
Sure, I can go first. From our perspective, anyone building ML models, essentially, anyone needing ML models within their workflow, what we would like to see is a move to modularity of models. So rather than AI developers having to go and get the OpenAI API and rely on that as their way of accessing machine learning, they should be able to build models in their own way across the landscape of devices they need to. So if you're building a model for an individual, maybe actually you do a bit of personalized modeling on the device, and then you do some remote modeling on a kind of larger scale data center somewhere that includes information from the internet, but the connection between those two things is just seamless. So you can send parameters from one side to the other, you can scale across devices when you need to. As a developer, you shouldn't have to think about which large scale data center model am I accessing and who am I getting it from. You should just be able to use this kind of open space of models. We think about it a lot like the internet. So like when the internet moved from kind of read-only to read-write, and people were creating websites and they were putting expert knowledge into those websites, and you could have your own kind of corner of the internet. The same thing can happen for models. You can have pieces of models that are experts in different areas, and you can compose those on the fly, but it requires this big shift in thinking from an ML developer away from how do I use the OpenAI model in the best way to how do I create this kind of composable path through model space. And we essentially build all of the infrastructure for that, so we want people to just seamlessly access that.
Yeah, Guy, I'm gonna slightly change my answer to your question, because part of the reason we released Infernet before we did the Ritual chain was exactly to go get users and applications before we knew that we would have a chain ready, right? So first I'm gonna empirically talk about what we have, and then I'll talk about where I think we're going.
Please.
So Infernet's already been adopted by dozens of projects I can't count anymore, and has been processing a lot of, like, I think probably close to 1 million inference requests now. And historically what that's looked like in terms of what they've adopted comes from 2 or 3 sort of categories. One, I think it's very hard to ignore the crypto part of crypto and AI. And the reality is that the one thing that perennially has product market fit in crypto is capital formation. And that's why, for some reason, Bitcenter is great. and I think they've done some interesting work, but a lot of the more recent excitement around crypto AI has come from like these AI agents launching coins, and that's really just a proxy for capital formation. So Virtuals is probably the best example of that. We met Virtuals maybe like 6 or 7 months ago, and we were using Internet because they needed a way to coordinate, the actions of their LLMs with sort of like these on-chain incentives. I think broadly we're starting to see a number of companies that want to take some part of the AI stack and create some capital formation dynamics around them. And I do think that is and will continue to be a very, very important thematic. And I do think that like the earliest example of this is if you go back earlier this year, there's actually not a lot of liquid exposure to AI in public equity markets. So a lot of people were like bidding render and all these GPU networks as proxies. And in certain cases, I think crypto gives people better exposure to this very important technology than just buying things else, right? That's a very like crypto answer. And then I'll talk about like the very AI answer, which is that we also get approached by a lot of Web2 companies, specifically more on the application side, that have hit maybe like a plateau or don't know where to go with their chatbot companies, generative content, whatever it is, right? And they recognize that building as a protocol can make their users much more invested in their product than if they just charge them a subscription. A really good example of this is we work with a number of companies that not only enable people to spin up their own characters, etc., but also create like bonding curves for those agents so that people are incentivized to actually go and evangelize that. And the end product of that is that you don't just have users interacting with these chatbots on their websites, you have users like showing these chatbots on like Discord and Twitch and getting them integrated there because that drives flow. And that creates very, very interesting ownership dynamics around models. And then I think a lot of the work that we've been doing recently, which we will also be announcing today, is taking a look at the existing set of protocols in the crypto landscape and seeing where they can be better, right? I think a very real thing is that a lot of DeFi, for example, is not real time. It's not dynamic, it's not adapted to markets. Historically, it's slow. If you have like an AMM or a lending protocol, the parameters are need to be updated by governance, and it's very laborious, right? Models provide a very interesting way to give near real-time or real-time modification and create adaptive market predictions. So we have protocols in Virtual that are working on everything from doing volatility prediction for markets so that LPs on AMMs don't suffer from finding stale bids, to having models that dynamically optimize like loan to value ratios on lending protocols based on like the underlying asset prices. So it's maybe like the third or fourth one that we see as a lot of users coming in, where just take existing crypto protocols that empirically work with accumulated TVL or users and make them better. I think the last part, which is like very edge, I'll probably be the most vague about this, is that we've done a lot of very interesting work around the intersection of cryptography, AI, and game theory, right? There's been a lot of other places that have done great work in HTTP, is like a good example of what you can do here. But I think that changes the way that people can fundamentally interact with models, right? A good example of this, one thing that we do have working on this, is that models in their current state are single player. So like the user asks a model, they get it back. Crypto by nature is multiplayer. There's a notion of shared state, right? And not many users interact with the same shared state and collectively govern it. By combining the two, the simplest example is giving the model an address, right? And then creating some sort of coordination game on chain around who can control that model and do things with funds in that address. You can make AI multiplayer, because otherwise there's no notion of shared state in AI. Maybe you can argue that shared vector database may give that in Web2, but without crypto, there's actually no express notion of like multiple people can control a single model to access the same shared resources. And I think that will also lead to a lot of very interesting dynamics and protocols and games that are not yet fully realized, because that's very, very much on the edge. So that's also an area I'm excited about, but so far out there that we'll see where it goes.
Perfect. And Regan, I know you guys have some pretty impressive user numbers lately as well, so I'd love to get your perspective on where you think users will come.
Oh yeah, sure. So let me try to categorize it in this way. So for the most frequent kind of Web2 use cases, flight booking, hotel booking, ride-hailing, all these stuff could be potentially be integrated into our protocol, because AI agent will be able to help the user to do this stuff in a more proactive and more efficient way. In the sense that, think about right now, if you're going to call Uber, you have to open the Uber app, and then you will have to input your destination. And then you have to choose, you go like Uber X or Uber Black, that kind of thing. And then you click on like confirm, right? But instead of doing this, if you have like a personalized AI agent, So they will be able to know your schedule, and then they can just call your service and with your preference. And so, so anything like in this kind of Web2 user scenarios that could be potentially served by the AI agents within our world. This is just one side of that. The other side is that for any AI agents, I think it's not there yet. But as Jason Wang has mentioned, potentially there will be over 100 million AI agents in the next 5 years, and everybody will be a CEO of AI agent. So how those AI agents will be able to communicate with each other? And recently, I just talked to a guy that he proposed me an idea like, hey, why don't we have some like front-end kind of AI agents and the back-end AI agent, and then they can together to define a task, and then the right specs there, when they finish their job, they can just get the money allocated for them. So these are some kind of AI agents that can be really be doing work under our coordination framework. So I would say that any AI agent that can create value in the Web3 and the AI space will be the potential customers for PINAI. Yeah, and let's just see what the developers would come out of our protocol.
Perfect. I want to end by asking each of you, not about your own projects, but about something else you thought was interesting or inspiring this week. Let's have 1 minute, 60 seconds or less. Tell us what has nerd sniped you so far in the conference.
I think it's just a lot of kind of new ideas and try to learn from them. And especially I think in the kind of Web3 and AI space, like people have like crazy ideas. And I do see.
What's the craziest? Let's hear the craziest idea.
So for example, the other day I was talking to the virtuous protocol guy, right? And so they have their AI agent, and then that agent has some like TikTok account. And so, yeah, so not sure like whether this AI agent stuff would just like take over the whole social network.
Does it have to be crypto AI? Could just be AI?
Anything you've been nerd sniped.
Okay, this is like technically not this week, it's last week. But I just released a demo with Descartes AI that created a real-time AI generated Minecraft game. And I thought that was very, very interesting because actually Walden Yan from Cognition Labs said aptly that it feels like looking into an AI God's dream. And I thought that was very interesting though, because that was probably the first demo we've seen of AI dedicated hardware being used to generate like a very, very complex task in real time. You know, hopefully maybe some of those will come onto the original network eventually. But I think that was quite interesting because I do think that real-time generation beyond just text is going to become quite important. We already have to run like a bunch of people trying to do this, but that was very, very surreal because you can actually play that game as well.
I think for me there's a kind of somewhat long-running area of research in the ML world around understanding animal language, but it's gaining steam a little bit recently, and to me it's one of the most sort of like obvious use cases for generalizable unsupervised learning. The idea that we can take sensors, put them around a certain species of animal, and gradually learn their methods of communication to the point where we'll actually start to understand them is absolutely fascinating to me, and it makes me think within the next like 12, 24 months, I think we're going to see an absolutely enormous shift in our ability to understand various animals. And I think you'll probably, at the moment there's a lot of stuff around like whales and dolphins and things like that because we know they have pretty complex language. But I think what will really catch public consciousness is like dogs and cats and things like that. So if you can just generate these enormous data sets of these animals interacting with humans, interacting with each other, etc., we can actually, like in an unsupervised way, similarly to what we've done with language, with large language models, we can learn the communication of animals themselves and then potentially start to communicate with them. And I think that gets lost a little bit in our excitement around communicating with AI itself, because we get excited about, hey, I can make a model and it can act on my behalf, but this unlocking of our ability to speak to other biological species is like, it blows my mind.
Well, a very inspirational point to end on. Hopefully next year we'll have a dog on stage for the panel. Please join me in thanking our panelists.